Let's look at applications of quadratic equations. The first example we want to look at says that the length of a rectangle exceeds its width by 3 feet. If its area is 40 square feet, find the dimensions of the rectangle. So the first thing we want to do is let's just draw a rectangle and kind of label it. We know that the length is bigger than the width. So do you guys want to let the width be x?
Yes.
Yes? Okay, so let's let this be x. So the length is what?
X plus 3.
X plus 3. And then we know that the area of the rectangle is about 40 square feet. How do we find area of a rectangle? Length times width. So we know that the area, or the length times the width, must equal 40. Then if I distribute the x, I get x squared plus 3x equals 40. And we have a quadratic equation to solve. So we can solve that quadratic equation using one of 4 methods. Now, not all of the methods would work, but we have 4 options. We can solve by factoring, the square root property, completing the square, or the quadratic formula. Typically, if you can, just get it equal to 0 and factor it, especially if the numbers are kind of nice. If not, go for one of the others. In this case, I can move the 40 to the left. Will that factor? Any ideas?
8 and 5.
Let's try 8 and 5. So x and 8, x and 5. We need 1 minus 1 plus to get a positive 3 in the middle. So how about positive 8, negative 5? And those are our 2 factors. But I haven't solved yet. What are the 2 solutions? X plus 8 equals 0, and x minus 5 equals 0. So it looks like negative 8 and positive 5. What are the units here? Feet. So either x is negative 8 feet or positive 5 feet. Which does it have to be?
5.
Positive 5. It has to make sense. So we can't have negative 8 feet as the width of my rectangle. So we're going to throw this one out simply because it doesn't make sense in a real world situation. So we know that x equals 5 feet. If x is 5 feet, and that's my width, what's the length? Well, whatever x plus 3 is, right? Which in this case is 8 feet. So there are the dimensions of my rectangle. Another way you could write that is 5 feet by 8 feet. It doesn't really matter to me which. On a college campus, a sidewalk is 85 meters long. All right. It says represented by red lines, so let's pop some red lines in here. This is your sidewalk. This area all through here. In total, that sidewalk is 85 meters long. And it joins the dormitory, marked here at D, with the student center marked at C. But the students, of course, prefer to walk directly from D to C. If they do walk directly from D to C, that is 65 meters from here to here. How long is each piece of the existing sidewalk? So we want to try to figure out how far it is from here to here and from here to here. Now I know total that these two add to what? 85. So if I let this be x, how much is left over to use on this side?
85 minus x.
85 minus x. What shape is that?
Triangle.
What type of triangle?
Right triangle.
A right triangle. And a right triangle has to obey the law of the Pythagorean theorem, right? So we know that this side squared, this leg squared plus this leg squared must equal the hypotenuse squared. So we could use the Pythagorean theorem to try to help us solve this problem. We have x squared plus 85 minus x quantity squared equals 65 squared. So we have to square double square this parenthesis out. We have x squared plus, what's 85 squared?
7,225.
7,225 minus double the product, which would be 170x plus x squared equals whatever 65 squared is. What's 65 squared?
4,225.
4,225. That's where we are so far. So that gives us 2x squared minus,
Oh, dang it. Okay.
you're okay?
I wrote it down wrong.
Got it. So 2x squared minus 170x plus what? If we combine like terms here, plus what? Move the 4,225 to the left and we get 3,000 equals 0. So there's the quadratic equation we would like to solve. What are all four of those terms divisible by?
2.
2. Do you guys mind if I go ahead and reduce the entire equation by 2? Some of you see that as factoring out of 2, but since it's an equation, we can just divide all four terms through by 2. And that gives us 1x squared minus 85x plus 1,500 equals 0. Let's see if we can figure out a way to factor that. So this factors into x minus 60 and x minus 25. That gives me two possible answers for x. The first being x equals positive 60, is it meters? Or x equals 25 meters. And both of those are legitimate possibilities. They're both positive, right? Okay, so if x equals 60 meters, which would be this side right here, how much would this side be? 25, because 85 minus x equals 25 meters. So there's one possibility. One possibility is that this sidewalk from here to here is 60, and that leaves just 25 meters left over for this one. The other possibility is that maybe this sidewalk, the one we're calling x, is 25 meters, leaving how much for the other? 60. And there's really no way to know unless we went to the campus and walked it off to see which one was the longer of the two sidewalks.
So it's all of it.
So what?
Give out both of those squares.
Well, but they're basically the same, right? 60 by 25 or 25 by 60, so it really doesn't matter the order you list them. Unless you were told which one was the longer or the shorter, I would have to take it either way.
But would we need to put all 4?
No, you would only need to list one of each because they're the same thing. Now, if one were, say, 30 and 55 and the other were 60 and 25, those would be four totally different possibilities and you would. But because they basically just produce differing versions of the same two numbers, you're only going to need to list it once. But if you listed it twice, it wouldn't be wrong. If an object is thrown straight up into the air with an initial velocity of 144 feet per second, its height is given by the formula h equals 144t minus 16t squared, where h represents the height in feet and t represents the time in seconds since the object was thrown. How long will it take for the object to return to the point from which it was thrown? So let's jot down our equation. We know that the height off of the ground is going to equal 144t minus 16t squared. But I think I'm going to write it as negative 16t squared plus 144t. That just helps me see the quadratic first. I prefer for my squares to come before my linear terms. So I'm going to rearrange it like that. And I want to know the time. So I'm solving for t. So I want to know t when the height is what? I want to set the height equal to 0. I want to know when is it going to equal 0? When is it going to return to the point it was thrown from, or from the initial point, also known as the ground, unless we're told otherwise. So 0 equals negative 16t squared plus 144t. And we just want to solve that quadratic equation. Any ideas? We could complete the
Pull out
square.
16.
We could see if it's divisible by 16.
It is.
So there are tons of ways we could do this. So you guys want to solve it by factoring? Is that what you're telling me? Is that okay? Okay. So when we factor it, would you guys like to factor out a 16 or a negative 16?
Negative 16.
Negative 16? So let's take out a negative 16, and that will leave me with t squared minus what?
9.
Minus 9t. Hey, we should have also taken out a what?
T.
A t, so let's take that out. So now we have 0 equals negative 16t times t minus 9. It's as factored as we can get. Let's take each factor, set it equal to 0, and solve for the times. So we have negative 16t equals 0, or t minus 9 equals 0. So if I divide this through by negative 16, one of the possibilities is that t equals 0. The other possibility is that t equals what? 9. What are the units on both of those? T is the time in seconds, right. So 9 seconds and 0 seconds. Which of those answers do you think this problem is asking for?
9 seconds.
The 9 seconds. We already knew it was at the 0 height when I started the problem at 0 seconds before I threw it, right? So we knew it was at 0 then. They're asking you for the other time that it goes to, that it comes to the ground. So when does it come back to the ground?
After 9.
So they're asking you for 9 seconds.